Welcome to the first episode of the LabMatePod. I am your host, Alan Booth, Senior Editor here at International LabMate and Labmate-Online. Sitting alongside me today is my co-host and esteemed editorial colleague here at ILM Media, Jed Thomas.
Hi Alan, and no, I'm genuinely pleased to be joining you here today for the launch episode of the LabMatePod and to be talking through some of the interesting stories and articles of note from the last few weeks. We've got a jam-packed and varied episode coming up, haven't we?
Absolutely, so let's dive in. There have been some notable developments in the life sciences of late and some rather amazing news from an extraterrestrial laboratory in the field of separation science, but we'll get to that in due course.
To let you know how things will work on the pod, the plan is that we're going to follow the top news stories that are currently available to read on the LabMate website, which you can find at www.labmate-online.com.
Yes, we'll be taking a broad overview of just 5 top items. If you'd like to read these stories, which all of course include signposting to the original science and published papers and so on, please click through to the website, which Jed has already said, can be found at www.labmate-online.com. Of course, for the sake of good housekeeping, I'll also add links to the stories in the show notes.
And of course, there's always much more to read online. Daily updates of news and much longer feature and analysis articles.
Yes, to make this podcast digestible and concise, we're only going to be able to take a snapshot of LabMate's reporting, but there's much more great content on the website, which is being updated all of the time.
Okay, so let's start. First up, we've got some rather concerning news regarding an avian influenza subtype, which is H5N1, and its growing potential to be a human pandemic pathogen. Something to take notice of, given that we've just passed the 5-year anniversary of COVID lockdowns around the world.
Yes, I hadn't thought about that with the COVID anniversary exactly, but it's a timely moment to discuss H5N1. Okay, so this story is in 3 main parts, and we've published a couple of different items. Firstly, we reported on an open letter which was published by the American Association for the Advancement of Science, which addressed the growing zoonotic threat which is posed by H5N1. As they noted, and I quote, "The virus has crossed species and already adapted to mammalian hosts. The AAAS is raising the alarm because this virus is now being found particularly in dairy cow herds in the United States and is already at a pandemic level in the wild bird population."
Okay, so in order to address pandemic preparedness, does the annual flu vaccination that many people have present a pathway if the virus was to jump to humans?
Well, of course, H5N1 has already infected and sadly caused the death of a dairy worker in Texas because of zoonotic transmission directly from an infected cow as opposed to an infected bird. So the virus is already adapting to intermammalian infection. To address your question, I don't think we're ready to actually be able to do that yet with the current vaccine technology. The AAAS view is that this type of flu vaccine is inadequate to scale to the threat. Their recommendation is to, and I quote again, develop rapidly a scalable pandemic influenza vaccine building on models such as we've seen in Operation Warp Speed and enhance collaboration on new technologies such as mRNA-based vaccines and vaccines using novel antigens.
Okay, just to let everyone know, that article is called Viewpoint, Prepare Now for a Potential H5N1 Pandemic. But as Alan said, we'll put links in the show notes below. What are the other parts of this story then?
Well, the second part is a brief aside here in the United Kingdom, where we had the world's first case of avian flu having been detected in a sheep, found in a single animal on a farm in Yorkshire, England. And that was because of a routine precautionary test of the flock as it was being kept on a site which had previously been where they'd found cases of avian influenza in birds.
Okay, that's not good news. It's coming closer to home now. But I suppose it's only to be expected since birds do undertake summer-winter migration.
Well, exactly. I do want to note that the UK authorities responsible for testing at Department for Rural Affairs and Agriculture have announced that no of the sheep in the flock were found to have H5N1 and the infected animal was culled and the flock is going to be monitored going forward.
Okay, some good news then. What's the final part of this story?
Well, that's where artificial intelligence takes its first bow, and I expect there'll be many more discussions of AI as we continue with further episodes in this podcast series. So What I reported on was a research team from the University of North Carolina at Charlotte in the United States, and they used a computational model to examine immunoprotein interactions of variants of avian influenza. Their work has concluded that the H5 family of viruses in particular, which would include H5N1 in humans, has begun to evolve in such a way as to escape human immune responses, whether that's from a previous infection of an H5 virus or crucially through vaccinations that we have on an annual basis.
So how did they actually go about doing that then?
I'm glad you asked me that. Of course, to read about this in detail, please go to LabMateOnline.com, but here's the précis. So UNC Charlotte research team used real data from patients who'd had flu infections between 1996 and 2018, and they examined the viral proteins which were bound to neutralizing antibodies obtained from infected patients, but also importantly from vaccine recipients. The paper shared results that had analysed 1,804 viral protein host antibody comparisons, and the work showed that there was an overall worsening in the antibody affinity to the location site on the virus protein, family protein, and that modelling of the trends of the virus's evolution suggested that future H5 type viruses showed a trend of weakening binding affinity of a wide variety of existing antibodies. So basically it's vaccine escape, but it's also escape from previous kinds of infections, from flu itself, which is worse news indeed.
Okay, so yeah, correct me if I'm wrong, you mentioned vaccine escape. Is this very similar to what we saw with all the new COVID-19 variants and things like that?
Yeah, it's a very similar kind of process, but I think it's the first time the work's actually been done in influenza and has been modelled into the future by looking at where it's come from in terms of evolution and then extrapolating with a computational model about where it's going. Let me just finish off that point by quoting what the UNC Charlotte team said. They said the virus strains pose an enhanced risk to human health, especially given exposure to a previous vaccine candidate virus means the vaccine will be less effective, based on measurements of how much the virus has evolved in recent years. So the findings of the research team at UNC provided an indicative evidence that avian influenza poses a significant ongoing threat to both global agriculture and was of increasing alarm for human health.
Okay, perfect. Always great to start on a cheerful note. Shall we move on? We have some research news in immunology, I believe.
Yes, this next item was LabMate's top performing post in March and is in some interesting and good news. The piece was called Cracking the Code of Antibodies in a Newly Identified Blood Clotting Disorder. And the story is about an international collaboration primarily between researchers from McMaster University in Canada and Flinders University in Adelaide, Australia, but with wider team members including those from New Zealand, France, Spain and Germany.
Now, I'm sure many of our listeners would have heard of rare blood clotting disorders in the news over the past few years, particularly the type that was associated with the now discontinued AstraZeneca vaccine, which was called Vaxzevria. Is this similar to that?
Yeah, that's right. So that disorder was described as vaccine-induced immune thrombocytopenia and thrombosis, more easily remembered as VIT, with two T's. But how this research has advanced the knowledge base is that this new VIT-like disorder did not respond to treatment with anticoagulants, as you would expect, but that it is being identified as an immune response-driven disorder. It did respond to an unusual combination of treatments, such as high-dose intravenous immunoglobulin, a Bruton tyrosine kinase inhibitor, and plasma cell-targeted myeloma therapy. Staying on immunology and vaccines, and especially timely considering the ongoing tuberculosis crisis in Kansas City in the US, another team of Australian researchers has developed a candidate tuberculosis vaccine based in our mRNA technology. Over the course of our history, that's human history, TB has proved to be humankind's most deadly infection. And with that thought in mind, it is astonishing to think that the BCG vaccine was brought into use more than 100 years ago and is still our only defensive tool. TB is the leading cause of infectious disease and responsible for around about 1.3 million deaths a year. As the team said, and I quote, "This study is an important step in demonstrating that mRNA technology is not just for viral infection like COVID-19, but could also be a game changer for bacterial disease like TB." And that's because mRNA vaccines offer a scalable, cost-effective and adaptable platform that can be rapidly deployed, which marks an improvement on older vaccine technologies.
Wow, that's fascinating. I must admit that I'd missed the fact that our mRNA vaccines had not been deployed against bacterial pathogens like tuberculosis. Anyway, sticking with bacteria, I know this next subject is one which you follow very closely indeed, and it relates to antimicrobial resistance.
That's right. So my next update broadly, I think, can be described as very good news indeed. So antimicrobial resistance, as we know, is a looming threat in all healthcare scenarios and has the potential to be as serious as any pandemic threat. It's more than unsettling to consider how bad it would be to go back to how life was before antibiotics were freely available. So to hear that another team from McMaster University in Canada, this time led by Professor Jerry White, has published a paper in the journal Nature with the astonishing breakthrough that his lab has discovered a wholly new class of antibiotics, which I think is the first time that a new class of antibiotics has emerged in more than 30 years. About 4.5 million people die each year due to infections caused by antibiotic-resistant microbials, and it's only going to get worse. So the news that this new molecule, which is a lasopeptide called lariocydin, is a big step forward. It's an entirely new molecule, Jed, with a new mode of action, and it comes from rather prosaic origins, which is dirt that was dug up from a backyard in Hamilton, Ontario. And the research team allowed the bacteria they found in the soil, and that was the many different kinds of bacteria, to develop and grow over the course of an entire year so that they could find those bacteria you might ordinarily miss that were slower growing and developing. The article is called Antibacterial Compound Found, but Master Team Discovers Wholly New Class of Antibiotics, and the link will be in the show notes.
And you have another antimicrobial resistance story where we've learned more about how bacteria exert dominance over other forms of bacteria.
Yes, that was a story which was called Parade of Pathogens, and it's out of the University of Pittsburgh School of Medicine, where a microbiology and immunology graduate student, Emma Mills, examined genomic sequence of 710 bacteria called vancomycin-resistant Enterococcus faecium, which thankfully we can abbreviate to VREFM, and found something rather remarkable. It should be said that unfortunately VREFM kills about 40% of the people it infects, and is a particular risk to immunocompromised and hospitalised patients. From the data set that was examined of samples which have been taken from patients infected with VREFM, all of which were in a healthcare setting, Mills saw that a dominant strain of VREFM emerged over the course of a 5-year period in more than 80% of those infected, when compared to an initial variety of 8 strains. Does that make sense? So it sort of shrunk down over the 5 years from 8 strains to 1. But what was even more of a surprise was this proved to be a global phenomenon when Mills accessed publicly available genomic libraries of more than 15,000 VRFM genomes that had previously been collected between 2002 and 2022. The dominant strain that emerged was using a very potent form of a bacteriocin against the other types of VREFM, its literal bacterial family members, and which we think now can be examined as a new form of therapy. But not only that, the fact that one strain has emerged as the dominant threat means that when we do develop new therapies, we only have a single target to aim for rather than sort of moving targets all over the place.
Yeah, that's remarkable. And it's fascinating that what was first thought to be a local phenomenon proved to be happening worldwide. And it's, yet another example of how important it is to make data available for international collaboration and investigation, I think.
On that note, I'll take us on to the next item, which deals with even smaller organic molecules, but this time on a planetary scale. So, okay, Jed, it looks like we've discovered life on Mars. Are you impressed?
Pretty impressed, but can you tell me how exactly?
Well, it's not Little Green Men or anything quite so complex. The Curiosity Martian rover, which has been on the red planet since 2012, has discovered yet another carbon compound that is commonly found on Earth associated with organic life. Previously, it discovered methane and chlorobenzene, and the SAM lab, that stands for Sample Analysis at Mars, which is within the Martian rover and is a project run by a French research team, has this time found alkanes. So that's carbon chains which are up to 12 carbons long. The methods that they used on board the lab to identify these chemicals were gas chromatography, a quadrupole mass spectrometer, and a tunable laser spectrometer, which the tech is fascinating and well worth a read on LabMate. The headline, Carbon Chain Molecules of Unprecedented Length Have Been Found on Mars.
So, and I'm sorry if this is a stupid question, Alan, but why are alkanes indicative of organic matter?
No stupid questions, Jed. The SAM labs that are sample processing involve heating what they find to around 1,000 degrees Celsius to be able to then put them through the chromatography and the spectrometry. And that has resulted in the confirmation of the existence of alkanes. But this process is by nature sort of destructive of the original sample, which was thought to be a carboxylic acid, or if you are concerned for your heart health, you might know them as triglycerides. And again, these are most often associated with organic formation, even though it is possible that they can be formed with volcanic activity as well.
Well, that will certainly change how I look at the night sky in the future. Now, we're almost out of time, but you have one more item to squeeze in, don't you?
Yes, I do, and kind of an and finally item for you, which we published on the website on April the 1st, that's April Fool's Day. Now, I know when I mentioned this to you in the office, you'd never heard of this research, but I promise you it is all true. It's a retrospective, the story I've written, and I urge you to go and read it. The title is The Case of the Disappearing Teaspoons, a longitudinal cohort study of the displacement of teaspoons in an Australian research institute. The link to the item will be in the show notes. Now, the title gives you a big clue about what's going on, but this paper published in the Christmas issue of the British Medical Journal in 2005 is still a good object lesson in longitudinal study design. At the head of the paper, the authors wrote, in January 2004, the authors found their tea room bereft of teaspoons. Although a flunky was rapidly dispatched to purchase a new batch, these replacements in turn disappeared within a few months. Exasperated by our consequent inability to stir sugar and to accurately dispense instant coffee, we decided to respond in time-honoured epidemiologist's fashion and measure the phenomenon. So 20 years on, disappearing teaspoons still serves as a funny and insightful commentary on the behavioural challenges of humans in spaces they must share with teaspoons. I'm sure that's the conclusion.
Brilliant, yeah. I really thought you were playing an April Fool's on me when you first mentioned it, but I googled it and it was actually real. I think that's a great place to end today's podcast. Little reminder that scientists can actually have a sense of humour.
Yes, that does bring us to the end of our time today for this premiere edition of LabMatePod. Thank you very much to my co-host Jed Thomas for your insight and editorship of the pod script and presentation.
Thanks very much, Alan. It's been fun and informative. Bye for now.
Also, my thanks to you podcast listeners for downloading this episode. Please subscribe so you don't miss an episode, and please share a link to the show with your colleagues and friends. Anyone with an interest in life sciences, whether by email or on social media, it'll really help to grow the audience for this project. LabMatePod is hosted on all mainstream podcasting platforms and on the Labmate-Online.com website. It's available for free. If you'd like to contribute editorially or support the podcast through sponsorship, please drop me an email at alan.booth@ilm-media.com. The other details I've already mentioned, alongside email addresses for the production and commercial teams, will be included in the pod's show notes. Thank you and goodbye until next time.